This is the second part, I think, of the Solartron 7150 repair. It was all working absolutely fine until I started using it a bit more regularly, and it became a little bit unreliable. Sometimes it wouldn't auto range, and you gave it a tap and it would clear and it would work absolutely fine again. Now, I resoldered a load of connections around this is the sort of area that does all the range selection, and I've resoldered some of the joints around there, and it progressively got worse and worse and worse, and actually now wouldn't auto range at all. If you set it into its lowest range, it would show you an over voltage. So if I was setting it at about 10 volts, an input of 10 volts, so it would over range, and then the next range up would show 0. So basically what it was showing to me was that the relays weren't passing the voltage through. Now, here are 3 of the relays I've taken out of the board this afternoon. Now these relays are made by a company called Pt2, and they're still in production actually, this company, but a relay this build and this size, they're all the equivalent replacement now, is about £10 each. Now I think I probably only need one. I've checked these other 3 relays, they're fine. The last relay, which I've actually left at work, I think, or it's on the bench somewhere, was totally open circuit on the winding, so it just wasn't activating at all. I also found that the ohms range was a bit intermittent, but I have actually found it since then. I don't know if you can see here, let me zoom in a bit so you can see, zoom right in, this wire here is actually broken, this wire here that goes to the board. Now what that does is that takes the wires from the front panel and feeds them into the back. I can actually run it on the rear panel connections, but at the moment I'm going to try and run it on the front. I want to try and get it working. Also, hats on, hats off. You were looking for the Rome point here, and that's on this board here, as you can see. Let me just get it in view. And there's your 0 volt point connection there. So anywhere on this point is 0 volts. That's where you're looking for. So that's I don't know if the enhanced version that you've got is the same, but certainly on this unit it's quite clearly marked on the board. Okay, so what I'm going to do is I'm going to refit the relays that I think are okay, but I'm just going to buzz them out with the meter first, just to see if they're testing okay still. So all I'm going to do is I'm going to supply a voltage across them and just make sure that they latch on and latch off, and they're clean. The problem with relays like these, they pass very little current, and because they pass little current, the relays become sort of oxidized. And what happens after a while is that they don't make a very good connection, and they just deteriorate. So what the problem is, what you need to do, and I don't think they were invented in these days when this thing was being made, is you need to use mercury wetted relays. Obviously these aren't, well, as far as I'm aware these aren't, but I'm just going to actually apply some voltage across them. Now, these relays haven't got a diode in them, but a lot of relays have. The replacement relays I've got here, I don't know if you can see here, I've got to put some more light on the subject, it might help you. These relays here, they've got a diode in them, and what the diode does is it protects the rest of the electronics from back EMF. Similar to an ignition coil in the car, if you applied a DC current to the primary of the winding and then remove it quickly, you'll get a big EMF electromotive force come back through the winding with a big spike of voltage, and that will blow up transistors and things. So diodes are fitted to protect that sort of problem. Now I'd imagine that there's a diode protection on the board somewhere, and I can see a number of diodes on the board, so that's probably there. Back EMF is done on the board. But you have to bear that in mind when you're applying DC voltage to the coil, that you've got it around the right way. So let's just check, see what we got. I remember which one's which. I didn't mark. Oh, I marked it up here, I think. That's the new relay. Okay, I can hear it clicking. So there's our relay contacts. So if I connect my continuity tester, just connect my fluke up to the connections just to make sure they're good. And what I'm looking for, I don't know if you can see it's just difficult to tell whether you can see it on the small screen, but I'm looking for is a I think it's pretty best there. I'm looking for 0 ohms when the relay closes. Okay, so the relay's closed now. I'm on diode test at the moment, but just turn the power off to the relay, and that's open. So let's just check our resistance. See, you see, it hasn't gone to. It's 1.2 ohms, and that's not really good enough. Let's give it a tap, see what it does. Now it could be because of the length of leads I'm using, but I'm more than likely it might be a bad connection here actually at the probably not too bad actually. Just activate it a couple of times. It's pretty constant at 1 ohm. Now what you can actually do is you can apply a little bit of current through the relay just to clean off the contacts, but you have to be very, very careful because they're very sensitive. And if you're using a bench power supply, even though you've probably got the current limit turned down, you have to remember that a lot of the bench power supplies will have a smoothing capacitor on the output, and that will give a big spike of current, so you'll probably actually trash the relay. So I think I'm going to go with that one. I'll just check the others and see what they're like. So that one's about 1 ohm closed, and it's clearly working. So let's try these other two here. Now they've all got slightly different part numbers on, but they all got the same resistance to the core, to the winding, and and all normally open, so I can't see any difference. See, that one's 1 ohm as well. Up slightly to 1.1. No, it's about 1 ohm, so that looks good. If I actually short these two leads together, that's the way to tell, isn't it, if it's my leads or not. We'll get 2.5 ohms. The trouble is I'm using these crappy Chinese crocodile clips. They're good for a quick connect up, you know, a quick hash up, but they're really poor quality and not to be trusted. So let's try the last relay. Okay, so the relays are all, those 3 relays are good. So I'm going to replace those 3 relays. Now I'm going to replace them where they came originally, only for the reason that I just don't want to mix them up. I've got a photograph of where they all went. So there's 3 different relays. I'm going to replace those in exactly the same place they came out. So just check. I took a photograph last night on my phone, so we can easy enough find out where they went. Okay, so relay B is a 505, which is that one. Relay B, yep, that's that one. Relay C is a 085, that's that one. And this one in the corner down here which is relay. Yeah, it's this one here, and that should be 86, so that's where they come from. So let's get those put back in. I'll probably have to straighten the pins out. You have to also bear in mind that with these particular boards, they're plated through holes. Now if you're on soldering, you need to be very careful. I actually got someone at work to do this. He's a really high quality solderer. Highly trained, and he removed it with a special tool, a proper desoldering station. I could do it, don't get me wrong, but I just rather him do it because I know that he's less likely to cause any damage to the boards. He's working with these sort of things all day long. I bet he was really chuffed when I gave him a bit of homework to do for me, but he obliged and took them out for me, so that's good. Let's get these pins cleaned up. off the excess solder. Now what I plan to do is I replace these relays, certainly the ones that have tested good, and then I'm going to fit the other relay upside down. I think the reason I'm going to fit it upside down is because the pinouts are totally different, and the whole footprint of the relay is smaller. But it is a mercury wetted relay, so it should prove to be very reliable. So let's just try and get that to line in. Get the pin straight. Let's take these out for a second. I've got a bit of a problem trying to get one of the pins back in for some reason. Holes look clear, maybe the alignment's not quite right. I think 4 wires would be quite easy to get in, but okay. I think what's happening is the pins are slightly crooked, so something simple, isn't it? You get 2 in on one end and 2 on the other, but not at the same time. Then you have to, of course, they only have to be slightly out of line. They won't line up. Definitely looks like one's bent in slightly. What I'll do is I'll pause the video, and once I've got the relays in, I'll continue. Right, I've got the new relay in. I've replaced the existing relays that are okay, and now the new relay is in position here. Let me just zoom in so you can see what I've done. It's a bit awkward because the footprint of most of these relays are different, and this is a mercury wetted relay I've fitted. Just zoom in. So this is the relay I've replaced, and you can see what I've done is I've actually mounted the relay upside down on the board, and I have glued it. Actually the glue's come loose, but I'll re-glue that before I box it all up. So basically these are the relay contacts here, and these are the solenoid here. This relay has got a diode in it, so it's imperative you get the diode condition around the right way, voltage around the right way, so you're not going against the diode. And the diode is actually working as a EMF protection. There are a few other things I need to mention about these meters that people keep pestering me about, and I realise I should mention these, and actually I've bit the bullet and bought a new part for it. These units, all the Solartron sounds like meters of this sort of era, are prone to input filter failure. The input filter, if you can see here, is just out of range here. This part here, this is a Schneider part, and these are made, I think they're made in, where were they made? Switzerland, I think. And they comprise of a sort of like a common mode choke and a safety cap for mains filtering. And the outlets, it's all wired inside here. Now, there is a problem with these, and there's a problem with a lot of safety capacitors that are sort of getting on sort of 30 years old. They can fail at any time, and what they're supposed to do is they're supposed to fail open circuit, but 99% of the times they don't, they fail short circuit. And what that results in a massive explosion of capacitor at the back of the unit, and it can actually cause a bit of sort of damage to the inside of the unit as well, because there's sort of shrapnel and stuff flying around. So be warned, if you've got one of these and it hasn't had the filter replaced, it needs replacing. There is a good chance that this meter will work perfectly okay, and I can run it sort of day in day out and it will never ever fail. But likewise, if I've left it on in the workshop when I go inside, I'm constantly thinking, oh, I better go and turn this meter off just in case it goes bang. So that's one thing. Another thing I want to point out is something that you probably need to get, I don't even know if you're going to be able to see on these boards because they're so small. Let me just see if I can bring you as close as I can. Just bear with me when I try and get some focus on here. Now then, let me just show you where I'm talking about. I'm hoping it sort of focuses closely. It's trying. Okay. Now then, where are we? Just here. Just here. You see this joint here? Now this joint to me, certainly under no magnification, looks like a bit of a dry joint with a sort of like a ring around it. Now what I've been doing when I had the problem with the unit, here's another one on the left here. I was going around and soldering everything, and that resulted in solder flowing from that centre pin to in that outer ring. Didn't think anything of it at the time, and there's quite a few joints like that of similar sort of layout, and there's lots of joints around like this one here. You're very close to this sort of guard around the side. Now that's when I started really noticing all the problems with the calibration had gone miles out. I couldn't get the resistance range to work. What I've found out is that I'd actually shorted out a screen. That's these rings around here are like a Faraday screen to protect the RFI and stuff like that. Here's another part here that's very prone to getting shorts, and I had to undersolder all this. As you can see, the flux, I haven't cleaned all this up yet. Removed all the flux from here, removed all the solder, and bit by bit the meter started to perform properly again. So I've got the relay in place, and the meter, it seems to be working absolutely fine. What I need to do now is I need to put it back together, and I'm going to do that now. I need to just give the board a scrub down. I'm not going to totally reassemble it because I'm still waiting for the input filter, which should come tomorrow, and then I can wrap this up hopefully. And I'm trying to get it calibrated. Now I've got a company coming in next month to work who said they'd have a look at it for me just to see if they could bring it into spec. Because this particular model, for calibration, you need to use a GPIB adapter. Now I've been wanting one of those for a while anyway, because I wanted to be able to connect it up to the Hewlett-Packard 8903 and use Peak Minute software to plot out charts as total harmonic distortion and various other things, power, frequency response. I thought it would be a great idea. And it's not that straightforward to use the software apparently. People have had a few problems getting it to work, but I'm going to go and have a go. The 8903 that's actually off camera at the moment hasn't got its GPIB controller in. It's not actually mounted in the unit, so I need to dig that out and at some point power it up to make sure it works. I've never had it working with the unit. When I bought the 8903, it wasn't working anyway, so I basically sort of just left it out of the unit whilst I was fault finding and never put it back in because I didn't have a GPIB controller. I couldn't see the point. Right, so let's get this back in. So that's the board back in. Now what I want to do, because we've got high sensitivity stuff around here, you know, mega ohms for the ohms range and high input source. I've gone around and checked all the joints, they all look fine. I'm basically going to give the unit now a clean down with isopropanol. So that basically involves squirting the board, especially around the areas I've fluxed, and giving a good scrub with a cut down brush. This is perfect for doing this. Just going over all the joints, making sure you've got the window open, because straight away you get hives of kite if you're using this stuff, especially on a warm day like it is today. Just go over the board. Not only does it make the board look nicer, but it removes any residue flux and the stickiness on the board, which could encourage stuff to stick in the future. So we'll give it a good rub down, and then what I tend to do is just give it a squirt off, then run off the board, any crud run off the board, and then basically let it dry. You could dry it off with a clean piece of towel paper or something like that, but you obviously have to just dab it because you're just going to rip all the paper up when you wipe it over the board. Basically that's, I think, really solved the problem with the Solartron. It was a sticky relay that's obviously going to cause problems with age, and if you look on the internet you can see quite a few people have had problems with the relay. Now I managed to find a relay on the RS, and I'll put a link to the part number on RS. About 26 quid including VAT, which is quite a lot of money, but it's worth it if I know that, you know, always sitting here thinking this meter's going to go bang at some point. So I did that when I ordered it. At the bottom of the RS order page, there's a sort of reviews on the item, and someone's written, who's got the exactly same meter as this, saying I bought it for my Solartron that blew up, and it fits perfectly. So that's reassuring, because it's a newer model of filter. It looks more or less exactly the same, but it's a newer model. And he said it fitted perfectly. He had to do a few modifications to clips and things, but it was straightforward to do. And interesting enough, it's listed under there. It said 36 people found this useful, so it's probably 36 Solartron users found it useful, which is excellent. I know the meter isn't anything special. It's not like a Hewlett Packard or a I don't know, some of the better makes that are going around, but it is a nice meter, and it's British as well, so I got a bit patriotic with all British stuff, because we don't make any decent stuff anymore. We don't really make anything anymore, which is, I'm afraid, not far from the truth. So bear that in mind. The relays are all normally open in their normal conditions, so when the relay's powered you should have 0 ohms across all the junctions. Just be a bit careful when you test them. And just, if you do resolder the joints, be careful of those Faraday screens around the joints, because it's very easy, as I found out, to short them out, and cause yourself a lot of headache trying to work out what the hell's wrong. But I basically found it by sort of backtracking, thinking, well, if the relay's okay, either I've zapped the logic and there's something wrong with the logic, or I've got a solder bridge or something. And sure enough, I had about 6 or 7 solder bridges. So yeah, waiting for the filter. I'm going to put the filter in. I'll probably do that on cameras, because it might be useful for someone else who's replacing theirs. And then we'll put it back, box it back up, and we'll get on with hopefully the HP 4261A. I don't know if any of my old followers remember that, but that was a LCR meter I bought from a seller in the UK who said it was working perfectly, and when I got it, it was all the knobs had been smashed off, because she just sent it in a plastic bubble wrap bag, stupid cow, and had totally broken all the knobs off the front of the meter, and told me it worked perfectly. When I switched it on, it didn't work perfectly. It was knackered. You know, it wouldn't auto range, it wouldn't read correctly. Basically tried to pull a fast one, so I sent her a message quite politely saying, it doesn't work, you've damaged it because you haven't packed it properly, I want a full refund. And she did. She gave me a full refund, and she said keep the meter. Well, she knew it wasn't going to work. She didn't even quibble. So that's, I've got to bought a spares unit for that, and hopefully I would like to get that going, because that's a really nice LCR meter. So that's the HP 4261, and that will be coming up in the next couple of days, hopefully. I expect to be delivered tomorrow. Maybe take a look, have a look at that on Friday. Anyway, thanks for watching, and more to come.